As a drivetrain specialist, Exidy is dedicated to the pursuit of quality and performance, as well as easy and reliable operation. The clutch is a mechanism that smoothly transmits and cuts off engine power to the transmission by engaging and disengaging. The clutch cover and flywheel always revolve together with the engine. When the clutch cover pushes the clutch disc against the flywheel, engine torque is transmitted to the transmission. When the driver steps on the clutch pedal, it releases the pressure plate that was pressing the clutch disc against the flywheel, disengaging the clutch disc. In this state, engine torque is not transmitted to the transmission. The clearance between the clutch disc and pressure plate when disengaged is approximately 1 millimeter for passenger cars and light commercial vehicles, and 1.5 millimeter for medium and heavy commercial vehicles. This engagement and disengagement is the basic principle of a manual clutch. The clutch cover's diaphragm spring is a disc-shaped spring that presses against the pressure plate and controls the amount of pressure applied. The amount of force that presses on the diaphragm spring is called the compression force. The graph that shows this change in compression force is known as the clamping load characteristic. This indicates the clutch disc's usable range. If wear exceeds this range, it will be impossible to obtain the necessary compression force and the clutch will slip. The release load of the diaphragm spring and pressure plate travel when the clutch disc is disengaged is shown by this graph, which is called the release characteristic. The other parts that comprise the clutch cover assembly are wire rings that serve as the fulcrums for operation of the diaphragm spring, strap plates that secure the pressure plate, and the clutch cover itself, which contains all of these parts. Next, looking at the clutch disc assembly, engine torque is first transmitted from the pressure plate to the facing material. This facing material is supported by the cushioning plate, which makes half-engaged clutch control possible. Engine torque is transmitted to the retaining plate and clutch plate, which hold the entire assembly together while actuating the torsion springs. The primary function of the torsion springs is to absorb fluctuations in engine revolution. Finally, engine torque is transmitted to the transmission via the splined hub. Fluctuations in engine revolution while idling are absorbed by this two-piece splined hub, which is coupled with several small dampening springs. It functions to prevent a chattering noise when fluctuations are transmitted to the transmission. The shock from engaging the clutch while accelerating is absorbed by torsion springs like this one. The cone springs, friction washers, and friction plate function to quickly stop the torsion springs from vibrating, reducing both noise and vibration. During engine braking, the torsion springs are compressed in the opposite direction compared to when accelerating to absorb the shock of deceleration. When driving at a constant speed, fluctuations in engine revolution are absorbed by the torsion springs and friction washers. This reduces the amount of chattering noise transmitted to the transmission and the differential gear. Let's take a look at important points to remember when replacing a clutch. When ordering a replacement clutch, it is necessary to check the vehicle's model, the year the vehicle was made, and the type of engine. This will ensure that you order the correct replacement clutch. The clutch is a very delicate component. If the clutch disc is even slightly damaged or deformed by mishandling, it will come into uneven contact with the flywheel or the pressure plate, preventing the engine torque from disengaging. The clutch cover must also be handled with care. If it is dropped, the clip could become bent, impairing disengagement performance or causing chattering noise. More severe deformation could shift the position of the dowel holes and make installation impossible. After securing the transmission with the transmission jack, pull the transmission off and lower it so that the crankshaft and top shaft are aligned along the same axis. After removing the clutch, confirm that there is no oil leaking from the crankshaft seal, the transmission, the operation cylinder, the master cylinder, or the clutch booster. Confirm that there is no wear, patterned wear, or thermal distortion of the flywheel surface where it comes into contact with the clutch disc. If any of these problems are seen, replace the flywheel with a new one or repair it by grinding the appropriate surfaces. The release bearing must always be replaced with a new one. Confirm there is no grease leakage or damage and that the bearing turns smoothly. Some clutch covers are pull type, and you can disengage the clutch by pulling the diaphragm spring. Exidy pull type clutch covers employ a snap-in mechanism for extremely easy removal and bearing replacement. Finally, confirm there is no end float in the top shaft and check the teeth for wear.